pharmaceutical company receives large shipments of ibuprofen tablets and uses an acceptance sampling plan. This plan randomly selects and tests 29 tablets, then accepts the whole batch if there is at most one that doesn't meet the required specifications. What is the probability that this whole shipment will be accepted if a particular shipment of thousands of ibuprofen tablets actually has a 5% rate of defects? All right, so the probability that the shipment will be accepted. Let's review. We're going to have randomly select 29 tablets, so that's 29 trials, and over here I have a probability distribution that I created for a previous problem. And I'm just going to reuse it because I set it up to recalculate for me. So now I have 29 trials, then accepts the whole batch if there is at most one that doesn't meet the required specifications. At most one. What does at most one mean? Because it's going to accept the whole batch, and that's what we're trying to calculate the probability of, that the shipment gets accepted. And it says that the whole batch will be accepted if there is at most one that doesn't meet the required specifications. So at most one defective. All right, so that means that our success here is defective. So we need to figure out our defective rate. And it's down here, ibuprofen tablets, 5% rate of defects. Okay, so let's change our P to 0.05 for 5%. Notice that my Q automatically recalculated, and so did all these values. Now, I could take this all the way down to 29. I could, okay, but I don't have to, although I could. I could do it, right? But I don't have to because I'm only interested in one or fewer defective tablets. So one, x being less than or equal to 1 is 1 or fewer, so it's right there. So that's the one we want. We're going to Control C, copy that, Control V, paste it, and we're done. Now, if you want to know how this was constructed, I will also link the video on how to set that up.